Agentic architecture begins when Claude chooses a path. It's not just answering a prompt anymore. For CCA candidates, this is a shift from prompt writer to system designer. A production agent must plan, act, observe, revise, and recover, all while staying within clear permissions, within tool boundaries and cost limits, and respecting human approval gates. A simple chatbot waits for instructions. An agent actively pursues specific outcomes. That sounds powerful at first glance until the system gives it vague goals and broad tools to use without limits. With weak logging and no stopping rule, prompt-only approaches fall short. Real business workflows need state management. They require retries when things go wrong. Context control is essential too. Tool governance must be enforced, and recovery plans are needed when the first attempt fails. A workflow follows predefined code paths. An agent dynamically decides what to do next. It chooses steps, tools, and observations based on context. The difference is architectural, not just visual. If every step is known in advance, use a workflow. If the path depends on results, uncertainty, or change, agentic design adds real value. The agent loop is the core primitive. It follows a cycle: plan, act, observe, revise. Claude forms a goal-directed plan first. Then it requests a tool to carry out the action. It reads the result from the tool's response. It updates its understanding based on that result. Then it decides whether to continue or stop. This loop transforms static prompting into adaptive execution. It also introduces new risks. Each iteration increases authority, latency, cost, and failure surface. A production loop needs boundaries before it needs intelligence. Define maximum steps the system can take. Set allowed tools for each stage of execution. Establish retry limits to prevent infinite loops. Set budget ceilings to control costs. Limit memory scope to avoid resource exhaustion. Create escalation rules for critical failures. Require approvals for irreversible actions. The agent should not decide its own authority. The system grants capability based on policy. The system measures behavior in real time. It interrupts autonomy when risk exceeds tolerance. Claude reasons, but the application governs. Your backend owns authentication and authorization. It handles validation, tool execution, and logging. It also manages policy checks for every request. Claude may ask to search customer or create draft invoer. It might request run test suite or summarize ticket, but only code decides if each request is valid. This separation keeps the agent useful. It prevents the agent from becoming dangerously sovereign. Agents are only as reliable as their tool surface. Narrow tools lead to predictable actions. Vague tools encourage improvisation. Each tool needs a clear name and description. It must have an input schema and output contract. Errors should follow a defined format. Permissions must be clearly set for each tool. The tool catalog is not optional. It is the agent's operating environment. Agentic systems fail when they carry everything into context. Good architecture picks only what the next decision needs. Use summaries, retrieval, memory rules, and task state instead. Avoid raw accumulation of data over time. Context discipline improves reasoning quality. It also reduces computational costs significantly and prevents stale or harmful information from taking over. An agent must know what to do when tools fail. It should handle conflicting results gracefully. When the goal becomes impossible, it must adapt. Recovery paths include retrying the action. It can ask for clarification if needed. It may choose a different tool instead. It can reduce the scope of the task. Escalation to a human is an option. It can stop and explain clearly. A mature agent isn't one that never fails. It's one that fails in a visible, understandable way. Subagents help when a context gets too crowded. They allow one role to gain sharper expertise. A coding assistant can delegate test generation. It can also assign security reviews to specialized agents. Documentation tasks can be handled by dedicated subagents. Refactoring analysis is another task for specialization. The main risk is increased coordination overhead. Use subagents when separation improves quality. Don't use them just because multi-agent diagrams look impressive. Agentic architecture can't be trusted by vibes alone. Build scenario tests to validate performance. Create golden tasks for consistent benchmarking. Track tool call traces for transparency. Implement regression checks to catch issues early. Set latency targets for responsiveness. Run failure simulations to test resilience. Evaluate if Claude chose the right tool. Check if it stopped at the right time. Verify error handling was safe and effective. Ensure user intent was preserved throughout. The exam mindset is simple: design, observe, measure, improve. For CCA candidates, the winning answer is never let Claude do everything. The winning answer is governed autonomy. Use agents when uncertainty requires adaptive steps. Use workflows when determinism is safer. Design the loop. Constrain the tools. Protect the data. Monitor the trace. Keep humans in control where consequences matter.